Rust's Async gRPC powerhouse.
You know, every single API call you make, it's like its own tiny little drama. A split-second negotiation between getting the job done fast, being resilient, and, well, keeping your sanity when a pager goes off at 3 in the morning. This quote just nails it. In the world of microservices, speed isn't just a nice-to-have. It's a promise. It's the contract you make with every other part of your system.
So here's what we've got on top. We'll start with that API speed contract and why it matters so much. Then we'll introduce Tonic as our hero. After that, we're going to tear down its engine to see how it really works, look at some code, and finally, give you the straight-up verdict on when you should be using it.
Okay, let's kick things off with the big why. We're talking about a speed contract, but what does that actually mean? Why is this constant chase for performance so absolutely critical for pretty much everything we build today?
Let's use an analogy here. Think about your APIs like they're a courier service. On one hand, you've got REST APIs. They're like the local post office. Everyone knows how to use them, they're super familiar, but man, they can be a bit chatty, a bit slow. On the other hand, you have gRPC. That's your express courier. It's all about optimized lanes, priority delivery, and packing everything into the smallest possible box using a binary format. It's just built for speed from the ground up.
So if gRPC is that super fast express courier, where does Tonic fit into this picture? Well, let's meet the star of our show, the tool that lets you actually use all that gRPC power right inside the Rust ecosystem. Okay, so building on that courier idea, if gRPC is the express service, then Tonic is the Ferrari truck in your delivery fleet. And yeah, I know Ferrari truck sounds a little crazy, but stick with me. This isn't just about being fast. It's about having a vehicle that gives you precision, total control, and just, absolutely jaw-dropping performance, all in one slick package.
So what is Tonic, really? Officially, it's a high-performance, async-first gRPC framework for Rust. Async first is the key phrase there. It's built for the modern world of concurrency. But the cool part is, it doesn't do all this heavy lifting by itself. Nope. It stands on the shoulders of giants, some of the most battle-tested elite libraries in the entire Rust ecosystem.
And here's the crew. You've got Tokio, the legendary async runtime that juggles everything without breaking a sweat. You have Hyper, which is the blazingly fast HTTP/2 engine that gRPC relies on. Then there's Prost, the protobuf compiler that translates data with crazy efficiency. And then there's Tower. Ah, Tower. That's the secret sauce. It's this amazing modular system for building your services. Together, this team creates a foundation that's not just fast, but also incredibly flexible.
All right, time to get our hands dirty. We're going to do a full teardown of Tonic, kind of like a mechanic staring at a Formula One engine. We'll go layer by layer and see exactly how each piece contributes to that unbelievable performance.
So the journey of a single request is this beautiful, efficient cascade down through the stack. It starts at the top with Tonic's nice, clean API. Then it flows down through the Tower middleware stack. This is where you'd handle things like auth or logging. After that, Prost serializes it all into a tight binary package. Then it's handed off to Hyper to be shot across the wire, with Tokio orchestrating the whole dance. It's basically a data expressway. To really get a feel for that Tower middleware concept, think of a really efficient restaurant kitchen. An incoming gRPC request, that's the order ticket. Each middleware layer from Tower is like a different station on the line. You've got a station for auth, a station for logging, maybe a rate-limiting station. Your actual server logic is like the head chef at the end of the line, putting the final dish together before it gets served. It makes everything so organized and, more importantly, reusable.
Okay, so this all sounds great in theory, right? All this architecture, all this power. But what does it actually feel like to use it? You might be thinking something this powerful has got to be complicated to write, but let's see just how simple it can be.
Everything starts with a blueprint. This is the proto file. Over on the left, we're defining our chat service contract, saying it has methods like send message and get messages. Then, over on the right, look at this tiny build.rs file. That little script tells the Rust compiler, hey, see that contract? Go ahead and automatically generate all the server and client code for me. It's like magic.
And this is what we get. We just have to implement the chat service trait that was automatically generated for us. I mean, look at how clean that is. We just write our actual logic for what to do when a message comes in. That's it. All the hard stuff, gRPC, Async I/O, HTTP2, is completely handled for us. Boom. You've just built a high-performance streaming chat server with barely any code.
And the fun doesn't stop there. Tonic is built to be customized. Need to check a token on every single request? Add an interceptor. Need complex stuff like rate limiting or tracing? Just plug in a pre-built tower layer. You can even swap out the entire data format from protobuf to JSON or whatever else you want. It's designed to be pulled apart and put back together however you need.
Okay, so you've seen the power, you've seen the elegance. Now for the million-dollar question. Is this Ferrari truck the right tool for your specific job? Let's break it down with some clear, no-nonsense advice.
So where does Tonic really kill it? For any internal service-to-service communication, absolutely yes. For any API where you're just pushing tons of data, yes again. For things like streaming telemetry or live data feeds, it's a perfect match. Now, where do you need to be careful? Browser-facing APIs are a no-go, at least not directly, because browsers don't really speak this dialect of HTTP/2. Same goes for mobile clients. For those, you typically use a proxy in between. The big takeaway is Tonic is king of the backend.
So when you boil it all down, using Tonic is about more than just getting raw speed. It's really about adopting a different philosophy of building software. It's about thinking in layers, defining ironclad contracts with protobuf, and building systems with the kind of precision and performance you'd expect from a finely tuned machine. It really is the Ferrari of APIs.
And that pretty much wraps up our deep dive. We've seen the why, we've seen the how, and we've seen the when. So now, I want to turn this question over to you. Whether you're already deep in the Rust world or just exploring high-performance options, think about it. How are you using gRPC today? Or maybe, how could a tool like Tonic completely change the way you build things tomorrow? Thanks for tuning in.